Hey, welcome back. So we're going to continue our review of writing vector equations of a line, but we're going to talk about how to write them all. Linear, parametric, and vector and symmetric lines. So if we look at the first one, this is our rectangular equation. This is a linear equation. Matter of fact, we already know that this is a line on the xy plane. And we know that's on the xy plane because z is 0. We're going to talk about that in just a few moments. So we want to write this as a parametric equation. So this goes way back to pre-cal, when you would just solve for y. We're going to do it the laziest way possible. If I solve for y here, we would just get, 3 minus 3 over 5x. Pretty easy. So to write this as a parametric, your teacher says, just do really easy. Let x be t. If you let x be t, y would be 3 minus 3/5 t. And that would be our parametric equations. Now we do have one more, a z, if we want to include it. Z would just be, again, just 0. We'll talk about this later. Vector equation, if I want to write this as a vector equation, well, we know we need a point, right? We need a point. So to get the point, easy way to do it, I can obviously just pick any point on the line right there, or I can just use the y-intercept here. Or I can let t be something. I can let t be 0, for instance. If I let t equal 0, from my parametric, I know x is going to be 0, and y will be 3. Oh, look, that's my y-intercept. Ha ha ha. All right, next, we need the direction vector. Well, the direction vector comes directly from the slope itself. This is my change in y, you might remember, and on the bottom is my change in x. So I can write my change in x as 5, remember, direction vector, change in x, and my change in y, which in this case will be negative 3. I had to put the negative somewhere. I put it on the 3. If you put it on the 5, that's okay too. So if I want to write my vector equation, it's going to be x, y. Now I'm just going to do this in 2 dimensions. If you did 3 dimensions, z is just always going to be 0, so that's kind of boring. But I'm going to use 2 dimensions. So xy would be my point, 0, 3, plus t times the direction vector, of course, 5, negative 3. And that would be your vector equation. Next, we want to do the symmetric equation of a line. Now, the symmetric comes from your parametrics. Since we already know x equals t, I can therefore say t equals x. I know that y equals 3 minus 3/5 t, and if you do a little bit of algebra, you'll get the following. T would become negative 5, y minus 3 over 3. Now, I am going to include in a second z equals 0. We'll talk about that in a second. But if I want to write this as my symmetric, I just said all my t's equal to each other. So I would have x equals negative 5/3 y minus 3. And I'm going to add this one, a comma. Notice it's not an equal to, comma, z equals 0. Now, let's talk about what this is. The first two just tell me my line. The z here tells me this is pretty boring. Get it? Zzz. I'm just kidding. The z here tells me that this line is on the xy plane. And we know it's on the xy plane because z is 0. So this is just more like an additional fact for us, that we have a line, it's on this plane. Another way to think about that, like what if z was 1? Well, then that would be, so if my paper is like the z-axis, or the xy plane, if z is 1, our line will be up 1 unit from that xy plane. All right, for question number 2, we're given a symmetric form of a line. So this is symmetric form of our line. And what we want to do is we want to write this as a parametric. So we're going to go the opposite of what we did here. So we know that t will equal 2x, t will equal y, and t will equal 4z. So if I want to write this as a parametric, I just solve for the variables. X would be 1/2 t, y would just be t, and z would be 1/4 t, or t over 4. And there's our parametric equation. But now we want to write this as a vector equation. So again, we need a point. So to pick a point, we're going to look at from our parametric equation. We're going to pick a value for t. Pick any number for t. The easiest, of course, would be 0. But you know what? I have no life. I'm going to pick 1. So if I pick 1, I would get 1/2, 1, and 1/4. Now, if you picked t equals 0, that'd be really easy. 0, 0, 0. But I'm going to stick right here. I'm sticking with my guns. Okay, I'm going to stick with that t right there. So my vector equation, oh no, I've got to get my direction vector. Direction vector. The direction vector also comes from your parametric. What is x changing by in this case? Well, x is changing by 1/2. What's y changing by? 1. What's z changing by? 1/4. Now, these are the same, but they're not related to each other, okay? One is a point, one is my direction vector. Had I picked 2, I know this would be 1, 2, 1/2, and that would be my point. Okay, so we can write, so you can pick any t value. You'll get a different point depending on which t value you pick, but your direction vector will always be the same. So my equation now, it's in 3 variables, is x, y, z, and that's going to equal, I'm going to pick my point, 1/2, 1, 1/4, plus t times my slope, 1/2, 1, 1/4. And that would be our vector equation. All right, that one's way too easy. Write the symmetric form of a line. Okay, but I do want to show you another way we can write a vector equation. Another way I can write a vector equation is as follows. If we use 0, 0, 0, okay, if the other way I could write it is this way. Remember this one, x, y, z equaled 0, 0, 0 plus t times 1/2, 1, and 1/4. Those are 2 basic equations for our line, given from each point that we picked. Now, this one's a neat one. I could also write this one as the following. Vector v equals t over 2 in the I direction plus t over t in the j direction plus t over 4 in the k direction. So another way I could write the vector is just in terms of the slope. Notice I'm not including my initial starting point there, just the slope itself. All right, so our next example here, we have the line 2x plus 3z equals 12. Now, this lies on the plane y equals 3, so we're going to talk about why this is important right here. So again, this is a line on the xz plane. And we want to write this as a parametric. So again, solving for a parametric equation, there's a couple ways we can do this. One, I could solve for z. Okay, if I were to solve for z, I would get the following. What's that become? 4 minus 2/3 x. And if I didn't want to deal with fractions, one thing I could do is I could let x equal 3t. And if I plug that 3t in, those t's are going to cancel right there. Okay? Now, you can remember this is from parametric. Old way would just be let x equal t. And if you did that, you'd be okay. I just want to kind of show you something. So my first parametric would be x equals 3t. And z then would be, well, let's see what z would be. Okay, this would become 4 minus 2 times x. But remember what x is. X is 3t. The 3's will cancel. So I just get t right there. And I do have a y this time. Y equals 3. So that would be my parametric equation right here. Next, we want to write this as a vector equation. Well, to write this as a vector equation, again, we need a point. So I'm going to mess with t. I'll let t equal 0. What do we get? 0. Y would be 3. Be careful, even though it's different. Be careful of the order. And z would be 4. Our direction vector, this where it gets a little bit tricky for us, okay? For our direction vector, well, what are the x's changing by? 3. What are the z's changing by? -2. That's where we get that change right there. And the last one is, well, what is y change? Because I'm dealing with three variables here, I actually have a change in y. But my change in y is 0. Remember, that's my change in x. And I get it from my slope. It's like looking at each part of a parametric as its own linear equation. The slope for x is 3 over 1. The slope for z is negative 2. This would be like a horizontal line, so its slope would be 0 for the change in y and the change in z. And when you write your vector equation, we get x, y, z equals 0, 3, 4 plus t times 3, 0, negative 2. And that would be our vector equation. To write our symmetric line, just come back up here from your parametrics, where we have x equals 3t. We would get t equals x over 3. Where we have z equals 4 minus 2t, t would equal z minus 4 over negative 2. And y just equals 3. So to write this as a symmetric equation, we can go x over 3 equals z minus 4 over negative 2. And such that, I like to use the phrase such that y equals 3. So what this is saying is that this will be on the plane y equals 3. This line will be on the plane y equals 3. Another way to look at it, that this is now parallel to the xz plane. We use a comma here, not an equal sign. If you said equals 3, that's going to be wrong. Because then you can say this whole equation is equal to 3, but that's a little bit different. That says that's not what this is saying. This is saying we're on this line such that y equals 3 right there. All right, go on to part 2. The next part is part 3, I guess, and we'll take a look at the last section here.